Is it visible slide? Okay. My camera is off. So the first numerical from our centrifugal pump. We will quickly revise the numerical to understand the basic of NPSL. And how to solve or deal with the various numericals from the centrifugal pump. So maybe in the numerical few data points will be provided, and by using this data you have to determine the net positive suction head or the power required to lift the liquid. So these are the two main objectives we are going to satisfy when we have to solve the numericals for the pump. Either you have to calculate the net positive suction head or the power required for the pump. So in this numerical we have to calculate available value of the NPSS, for which the pressure situations are provided at the suction and at the outlet or at the discharge line. Problem statement is very simple. We have to find out the NPSH available for a pump which is used for the benzene from an overhead tank. So the situation is like this. This is the location of your pump. It is going to lift the water from an overhead tank. This is the overhead tank, and water is to be lifted from that overhead tank. So instead of gravity, maybe when we design the actual process plant and its layout, some of the equipments may be at the ground floor, whereas few equipments may be at first floor, second floor, third floor, and so on. So it totally depends on what is your manufacturing process and how you are designing it on the basis of the various parameters. So your plant may be one-story building or it may be a multiple-story building. So according to the specification of the raw material and the process to be undertaken, the location of the equipment will change. So here we are having this overhead tank, and the benzene is to be pumped from this overhead tank to some another reservoir. So this overhead tank is operating under the vacuum. It is given as vacuum pressure in the tank is 700 torr or 700 mmHg. 1 torr means 1 mm of Hg. And the free surface of the liquid in the tank and center line of the pump is 12 meter. So free surface of the liquid, and this is the center line of the pump. This distance, that is the vertical distance between the pump and the surface of the liquid from the tank, is equal to 12 meter. So value of the Z is already provided. So you always have to remember that Z is the vertical distance. Either it may be from the suction line or it may be from the discharge line. So this is your suction line. This is the actual suction head available, because pump is located below the reservoir from which the benzene is to be transported. So it is your sump or the reservoir or tank from which you are getting your liquid, and maybe at some other location it will be delivered. Okay. Sometimes it will be feasible to install a pump at the base level, or Sometimes it may be installed directly above the tank or below the tank. So there are a lot of factors like gravity or how much layout or the location of that plant along with the retail infrastructure. So this location of the pump will change, and we have already seen the situation that for calculation of the NPSF, that will be always available NPSF. Okay, we are not calculating the required value of the NPSF. It is only available NPSF we have to determine. So yesterday we discussed that NPSS is what? It is the available pressure in the system. Then we have to add atmospheric pressure into it, and from that sum we have to subtract the losses because of the friction. Available pressure plus atmospheric pressure, then subtract the frictional head losses in the pump, and also subtract the vapor pressure of the liquid, because we know the definition of the boiling point. So if this vapor pressure will get exceeds than the atmospheric pressure, then the liquid will be in a boiling state. So when the atmospheric pressure or system pressure become equal to the vapor pressure, the liquid will get boiled, and that temperature is known as the boiling point temperature. That's why 1 atmosphere, if you are heating the water or boiling your water at the atmospheric condition, then 1 atmosphere is the system pressure. When the system pressure will become equal to the 760 mm of Hg, then water will boil. Otherwise, it will be under boiling condition or under boiling situation. So we have to determine the vapor pressure of the water when we are transporting it, because it should not be varied with the excess of the atmospheric situation. Otherwise, the liquid to be pumped will boil and it will form the cavitation. That is one of the very common phenomenon we are observing whenever there is a difference or wide difference between the atmospheric pressure and the vapor pressure. So to avoid the cavitation, we have to take care of the system pressure as well as vapor pressure of the liquid, which is a function of temperature. Okay. So available NPSS we have got as a available pressure plus atmospheric pressure. So in general we are writing it as the HSS, static suction head available, minus we have to subtract the frictional losses. So in the suction line it could be written as HFS, and in the discharge line it will be HFD, minus vapor pressure of the liquid, PV. So this is a very simple formula we have already discussed in the last session, HSS minus HFS minus PV. Now this HSS evaluation is a critical job. Frictional losses you can easily determine from the length of the pipe and diameter of the pipe, and from the properties of the liquid to be determined. It is just like the thing we have already learned in process pipeline design. So before calculation of the pressure drop, we have to calculate what will be the resistance in the pipeline. So frictional losses is suggesting the total resistances because of the viscosity of the pipe and the structure of the pipe, that is surface roughness. Okay. So HFS is already known to us. It is the head loss because of the friction, and it could be calculated by using the Darcy-Weisbach equation. Okay. Then this vapor pressure of the liquid, since it is the function of the temperature, there is already lot of data available for the vapor pressure of different commonly used liquids. So vapor pressure with temperature for the different organic and inorganic liquid data is available. You can search this data for vapor pressure from Paris Chemical Engineers Handbook. It is available in our library. Have a look at it. You will find the density data, CP data, vapor pressure data, enthalpy data, free energy data, everything. There are a number of reference books available to extract the data of physical properties and the chemical properties or various chemicals. So PV is known, HFS is known. Only issue is here or problem is here to get the value of the static suction rate. So we are saying HSS is to be defined as the P plus minus Z. This is the equation we are to use because it is the available pressure plus minus vertical distance from the surface of the reservoir to the center line of the pump. You will get the total static suction head. Now this P minus Z, there are two different situations again. From the location of the pump, we have to consider the sign convention of this Z, vertical distance. Now in this case, pump is located below the sump. हा संप आहे, सोर्स आहे, जिथून आपल्याला पाणी मिळतं, लिक्विड मिळतं. So location of the pump is below. So it is located below the surface of the liquid from the sump. So if it is located below the surface of liquid, then in that case Z will be positive. Is it correct? And there may be some kind of the situation like this. This is your sump. You are getting the liquid from this sump, and it is to be transported like this. Now free surface of the liquid is here. Pump is located, this is the center line of the pump. So pump is located above the free surface of the liquid. This is you don't have to concentrate on this tank. Focus here. Where is the location of the pump? This tank location, obviously we are having the two different tanks, reservoir and sump. So ultimately in between reservoir or sump or maybe above and below the sump, the location of the pump will be there. So instead of focusing on this reservoir or the tank, you have to focus here. Now this pump is located above the surface of the liquid from the sump. So in that case, we have to say that Z is negative. The same kind of principle we have used while designing the manometer or while doing the calculation with the manometer. मॅनोमीटर मध्ये सुद्धा एक हॉरिझॉन्टल प्लेन असतं. अबोव दी प्लेन जर असेल तर आपण काय करत जातो, ऍडिशन करत जातो. and below the plane जर असेल तर आपण सबट्रॅक्ट करत जातो. This is the general tendency we are following while doing the calculation. So these two situations may occur and accordingly you have to check the sign of the Z. So in our case we are having the overhead tank, and from that overhead tank benzene is to be pumped. So it means that pump is definitely below the free surface of the benzene from the overhead tank, and in that case we can say Z is positive. So this equation will change from P plus minus Z to P plus Z. So first of all, we have decided while solving this numerical, we have decided what we need to calculate, and after that one by one parameter is to be evaluated from the given equation or the equation we are undertaking to get our answer. So the first equation is to be written always. What is the objective of the problem? Objective is to get the value of NPSS. So I am going to write the first equation as NPSS is equal to HSS minus HFS minus PV. So that is our first equation. Now once you set your objective, your goal is now set. So from that you have to evaluate what are the known parameters from it and what are the unknown parameters. So NPSS is to be calculated. So it is your dependent parameter. म्हणजे NPSS ची व्हॅल्यू डिपेंड आहे किती पॅरामीटर वर डिपेंड आहे. 3 number of parameters are there which are unknown. So this one is known as dependent parameter, and these three are the independent. Now from this, you can easily formulate the relationship is equal to y equals to the function of x, y, or you can write it like this, p, q, r. Now there are three different variables p, q, r, s, or maybe some equation having the large number of variables involved in it depending upon the nature of the equation you are setting as your objective here. See, there is a very close connection to the mathematics. We are writing here the functional relationship. Y is the dependent variable, whereas P, Q, R are the independent variable. It means that by supplying the value of this P, Q, R, you can change or you can obtain the value of Y. Okay? So Y value is depend on the value of P, Q, R. So you have to select the proper value of P, Q, R to get your desired answer. These values are important. These are the independent parameters. It may be provided with the data in the problem statement, or it may be dependent on the other independent parameters. Sometimes all the three parameters will be defined in the problem. It may be possible for simple numerical, A type numerical. काय असतं दिलेलं असतं सगळं, you just have to put it into mathematical equation and obtain the result. But sometimes that will not be a situation. You have to calculate few variables based on the other type of the variable. So here in this case, HFS is given. I am going to write it in a proper way. Okay, so HFS is the total frictional head available. How much it is? The frictional loss in the suction line. Remember the word. So for the suction line, we are writing yes. So HFS is given as 1 meter of liquid column. Which is the liquid we are transporting? Benzene is the liquid. So all the parameters are to be expressed in terms of benzene only. Okay. So HFS value is given. PV is the vapor pressure of the liquid to be pumped or to be transported. So vapor pressure of the benzene at the given temperature is how much? 280 torr. 280 torr. So out of these three variables, two variables are known. Then the third variable. जेव्हा आपण सुरुवातीला इक्वेशन लिहितो तेव्हा त्या इक्वेशन मधला प्रत्येक पॅरामीटर तुम्ही खाली लिहायला पाहिजे. Then you have to substitute the value. If that parameter is not known, then you have to think about how to get the value of that parameter systematically by following the data provided in the statement. So HFS is known, this is known, this one is known. Question is here. HSS. So we have to write the third parameter as HSS, and we know it is to be calculated from the available pressure plus minus Z. Okay. So you have got three parameters: HSS, HFS, and PV. Now here in this equation number 1, HSS is the independent parameter. इथे तो काय होता? Independent parameter होता. But here in this equation number 2, it is the dependent parameter. Because this value is dependent on P and Z. This is the available pressure and Z is the vertical distance from suction line from discharge line. Vertical distance will Z. Okay. So from this equation number 2, HSS is to be calculated by using this equation, and we have to get a HSS. To obtain the HSS, what is the value of P? Available pressure. It is the vacuum pressure. So vacuum pressure is available pressure in the system, then it is 700 torr. Okay, one point is clear. या HSS च्या इक्वेशन मध्ये P and Z two parameters are required. P is provided, Z is also given. It is 12 meter of liquid column. Okay. How many equations we have got here? Although problem statement looks very simple, we know to solve the equation 1, we need equation 2. Or we need to solve equation 2 because this parameter in turn depend upon the other parameters or variable. So you have got HSS by using equation 2 and that value needs to be substituted here to get the available MKC. Now P is 700 torr, Z is 12 meter. Later on we will calculate the value of the pressure. Because pressure is 700 torr, whereas PV is 280 torr. So while solving the numerical, we have to consider the dimensions from the left hand side as well as the right hand side of that equation. So if there should be a dimensional consistency existed between LHS and the RHS, then only we have to proceed with the solution. I have seen when we were in the second year and appearing for the process calculation unit test, there was one numerical, quite many problem statement was there. So when we write the equation, we came to know that equation is quite complex for the individual material balance for the different components involved in the distillation. That was the unit operation we were learning. So we tried almost 1 hour to solve that numerical, but after the declaration of the result of that unit test, we came to know that what are the equations is to be written for that kind of the system that was not dimensionally consistent. So the answer was very simple. The equation is not dimensionally consistent and could not be solved. That was the answer. But we didn't think about it whether the equation provided to us is correct or not. तुम्हाला एक मोठं लांबचं इंटिग्रेशन दिलेलं आहे, पण लेफ्ट साइडचं युनिट आणि राइट साइडचं युनिट जर मॅच होत नसेल तर ते सोडून काही उपयोगच नाही. Each and every equation are to be dimensionally consistent to be authentic. Otherwise, it is what just a prejudice or some pre-assumptions we are making and then we are trying to solve the equation. So that should not happen. Left hand side and the right hand side units should be same. And here we can observe the head is to be expressed in terms of meter of liquid column, whereas pressure is being expressed in terms of torque. So there are two alternatives available in our hand. Either you can convert the torque into meter of liquid column, or this meter of liquid column can be converted into torque. There should be the consistency because this P is quite analogous to Z. Pressure and the analogous term for the pressure in the fluid mechanics we are using as a head. Okay? We learn about the Bernoulli equation, kinetic head. याच्यामध्ये मीटर मध्ये मोजतात. Friction head मीटर मध्ये. Velocity head मीटर मध्ये. Pressure head मीटर मध्ये. तर head म्हटल्यानंतर it is what in conjunction with the pressure. So it is the analogous term for the pressure, so that we can get the detailed idea about what we have to achieve with the design of the different fluid moving devices. So pressure in it can be expressed in terms of meter. And we know the relationships, basic relationship you always have to remember. There is no other way. So to remember these basic relationships, you need to carry out more and more practice of the various kind of the problem. So 1 atmosphere is equal to 760 torr, or it is equal to 760 mm Hg, or 101.325 kilopascal, or 14.7 psi, or 1.013 bar, or 1.01 kg per square centimeter. So these are few of the relationships you have to remember. Pressure, it is one of the relationship for the pressure. Similarly, there are few basic relationships for the temperature, energy, work, or length, or area, volume, density, and so on. So here we are going to use these two relationships only. One atmosphere is equal to this much torr, this much atmosphere, mmHg, and another one in terms of the meter of the water column. So in terms of meter of water column, it is 10.33 meter of WC. Is it correct? So 1 atmosphere, आपल्या बाकीचं काम नाहीये. 1 atmosphere equals to 760 torr or mmHg, and it is equivalent to the 10.33 meter of water column. Okay? So this is what we need here. So while solving the numerical, you have to write what are the units you remember for a given parameters. You can directly write in answer book or your answer sheet, so that you could not make the mistake that is repetitively happening with the units or handling of the units. So 1 atmosphere equals to 760 torr, or it is equals to 10.33 meter of water column. So we can calculate first. This pressure unit is to be calculated from torr to meter of water column, and then from meter of water column it is to be calculated to meter of liquid column. त्यामुळे pressure जे आहे, available pressure, it is the vacuum pressure. So yesterday I explained you how this vacuum pressure is to be converted into absolute pressure. Vacuum मध्ये काय ऍड करावं लागेल तुम्हाला? Atmospheric pressure add करावा लागेल. In that case, vacuum will be negative. So P is 700 torr, or it is 760 minus 700 is equal to 60 torr absolute. That value you have to consider for the pressure. Okay? This is vacuum pressure. We have added here the atmospheric pressure. अब below the atmospheric line आहे, म्हणून हा काही निगेटिव्ह आहे. काल प्रेशर स्केल मी तुम्हाला ड्रॉ करून दाखवली. So it is lying below the atmospheric pressure. That's why it is negative. So 760 minus 700. That will be your pressure or absolute pressure. So this absolute pressure from the torr to be converted into meter of water column, and it is to be converted into meter of liquid column, and you can get it here as a 1 atmosphere. You can directly write 760 torr is equal to 10.33 meter of water column. तर तुमचा तो किती टॉर आहे? 60 torr आहे अवेलेबल प्रेशर साठी. किती मीटर ऑफ वॉटर कॉलम होती? Then there is 280 torr for the vapor pressure. How much meter of water column are there for 60 torr and for 280 torr? त्यामुळे प्रेशरचे युनिट आपण कशामध्ये कन्वर्ट केले? मीटर ऑफ वॉटर कॉलम. ओके. And after that, from this meter of water column, you need to convert it into meter of liquid column. And this could be achieved by writing our basic relationship. We know that P equals to H rho G. pressure at any point can be calculated by using the hydrostatic equation H rho g. So we will write this equation. Pressure from the Pascal law, we know that pressure at a horizontal plane will be same. दोन जर प्लेन जर असेल तर इथे आणि इथे एक्झर्ट होणारा दोन्ही पॉइंटला एक्झर्ट होणारा प्रेशर काय असेल सेम असेल along the horizontal axis. So H rho g we will be writing for water and H rho g would be written for the benzene because benzene is the liquid here. Okay. So what we will be doing? We are balancing the column of the benzene with column of water. म्हणजे बेन्झीनचं जर एक कॅपिलरी घेतली तर तिथे किती प्रेशर आहे ते माहित पडतं. rise of the liquid level in that capillary, it is to be easily calculated. So if that pressure is to be maintained, जेवढं प्रेशर कॅपिलरी मध्ये बेन्झीन न एक्झर्ट केलं तेवढंच प्रेशर जर इन टर्म्स ऑफ वॉटर जर काढायचं असेल तर वॉटरची हाईट किती लागेल. लक्षात आलं ना कन्सेप्ट. वॉटरची हाईट जास्त लागू शकते कमी लागू शकते हे डेन्सिटीवर डिपेंड आहे बरोबर. So H rho g of water, column of water to be balanced with column of benzene. So we can write this similarity relationship and it could be extended as HW rho W g is equal to g is a constant. So it is HB rho B and g. So g from both the sides it is the constant. And at the atmospheric condition it will be acting with same intensity, so it is nullified. Now from this equation we are getting the height in terms of water बरोबर आहे. meter of water column, so this is meter of water column, this is meter of benzene or the liquid column. So HW we know density of water is 1000 kg per cubic meter. Density of benzene is provided here. How much? 870 kg per cubic meter. You have to calculate the height of benzene. Water ची height माहिती आहे त्यावरून तुम्हाला benzene ची height calculate करायची आहे. So HB benzene height is equal to HW into rho W divided by rho B. Put the value and get the answer. Rho W 1000 टाका, rho B टाका, HW एकदा याचा टाका म्हणजे याचं तुम्हाला लिक्विड कॉलम मध्ये मिळेल आणि एकदा इथे अगोदर कॅल्क्युलेट करा वॉटरचा कॉलम किती आहे. ओके करता येईल. जे ऑनलाइन मध्ये आहेत त्यांना समजलं का. ब्लॅकबोर्ड वरचं दिसत आहे का. हा ठीक आहे. आता कॅल्क्युलेट करा. अगोदर 60 टॉरला कन्वर्ट करा मीटर ऑफ वॉटर कॉलम मध्ये आणि व्यवस्थित घ्या. 3 पेज लागले तरी चालतं. व्यवस्थित एकदा प्रॉब्लेम सॉल्व करा. सुटसुटीत पण इथेच काही कोरडा ठेवू नका. झालं का. स्लाइड कडे बघू नका. इथे दिलेलं आहे सगळं. प्रोसिजर तुम्हाला एक्सप्लेन केलेली आहे त्या सिक्वेन्सने नोटबुकमध्ये लिहायचं. एका प्रॉब्लेमला 10 तास वेळ तरी चालतो तो समजायला पाहिजे. हा प्रॉब्लेम एकदा समजला की नेक्स्ट प्रॉब्लेम मध्ये काय अडचण येणार नाही. आता पण तुम्ही युनिट कन्वर्जन करता यायला हवं. z ची साइन माहित असायला हवी प्लस मायनस करायची. तुम्हाला एक्सचेंज करून सांगितलं आहे अबो बिलो. मला समाधान असेल तर विचारू शकता. Check the answer. What is the value of NPSH? So what is 60 torr? P equals to 60 torr equals to how much water column? What is the huh? 0.81 meter of water column. Please check your answer. And for this PV, what is the value for this 280 torr in terms of water column? 3.81. Okay. Now from water column, we have to convert it into liquid column. So what is the value of P? That is 0.81 meter of water column equals to how much meter of liquid column? 0.94. And for PV, how much liquid column? 4 point meter of liquid column. So each and every minute is now in meter of liquid column. Now you have to substitute it here. So NPSHA equals to HSS is P plus Z minus HFS minus PV. So P is how much water column 0.81 and liquid column 0.94 plus Z was 12 meter minus HFS. What is the value of HFS? 1 meter minus PV. PV is 4.37. Now this equation is dimensionally consistent. So what is the value of NPSHA? $7.56. येतं का तेवढं 1.5 येतं ऑनलाईन अटेंड करत आहे, आन्सर मिळालं का? এটা असं मिरर इमेज सारखं दिसतंय. Is there any setting for the camera? मेस्त्री मिरर इमेजच दिसतं का तुम्हाला? त्यांना दिसत मिरर इमेज नाही दिसत आहे ना ब्लॅकबोर्डची? अच्छा, म्हणजे इथे फक्त मला दिसताना ते मिरर इमेज दिसतं. माझ्या लॉगिन मधून मिरर इमेज तिथे बंद. हा, okay, then we will stop here. Denge sir is going to conduct this second lecture.